Your do now says create 4 equivalent ratios, 2 by scaling up and 2 by scaling down, using the ratio 30 to 80. Okay, so our ratio is what, Davian? What's our ratio?
30 to 80.
Yeah, 30. I'm going to write it over here so I have room. 30 to 80. What does scaling up mean? Scaling up. Kalia.
It's like the numbers are larger, but it's the same value.
Ooh, perfect definition. The numbers get larger, but they have the same value. So what do you think scale down means? Okay, Leah. Exactly. It's the same thing as what we wrote up here, except they get smaller but have the same value. Good. So let's make 4 equivalent ratios to 30 to 80. 2 of them will be smaller and 2 of them will be larger. Okay. How can I make 2 ratios equivalent to 30 to 80 that are smaller than 30 to 80? What could I do? 30 to 80. Turn and talk to your partner. How do we scale it down?
See what
Bring it back in 3, 2, you're at a level 0, and 1. Yes, ma'am.
It's starting to hurt my eyes looking at that without my glasses because it's so bright.
Oh, it's too bright. Is that better? Okay. Okay, Tara. We could use a tape diagram. Do I want to draw 30 squares and 80 squares? Ooh, no. How else could I scale down, Devin? Divide by
10.
Yeah, divide by a common factor, right? The same way we reduce a fraction, we can scale down a ratio. We just need a common factor we divide both sides by. So Devin chose 10. If we divide 30 by 10, we get 3. If we divide 80 by 10, we get 8. Now, it said we have to make 2 ratios by scaling up and 2 ratios by scaling down. So we have to scale down in a different way for our second ratio. Yes, Isaiah. I can divide it by 2. 30 divided by 2 is? 30 divided by 2 is?
15.
80 divided by 2 is?
40.
Do I have 2 equivalent ratios that are smaller than 30 to 80?
Yeah.
Yes. Now what do I have to do, Wesley? What else does the problem ask for? We got to scale up. Create 2 equivalent ratios that are larger. Okay, how do I do that? What do I multiply by? I could multiply by 10. 30 times 10 is? Ooh,
300.
let's try that again. 30 times 10 is?
300.
Yes, scare me for a moment. 80 times 10 is?
800.
Nice. So, what else can I multiply 30 to 80 by to get a larger ratio? Rihanna. How else could I make these 2 numbers bigger? Jordan? Sure. What's 30 times 30?
900.
What's 80 times 80?
600.
Tara? Yes, Tara. You could basically multiply it by any number. Absolutely. When you're scaling up, as long as you multiply by the same number on both sides, you'll get an equivalent ratio. It doesn't matter what the number is. Why isn't it that way when I scale down? What rules do I have to follow when I scale down that makes it different, Persephone?
Because you're going lower than 30.
Okay, I'm making them smaller. But why do I have to stick to some rules, right, Kalia? But when I divide, why can't I just divide by any number? Why can't I just divide by 3? Just pick a number and divide. Itzel.
Because they both have to have like the same common number.
Yes, you have to divide by a common factor because we have to do the same thing on both sides. Right? Okay, so move down to the second part. Write a ratio to describe the relationship shown in the table. Anybody get to this part on the do now? Nice. Liliana, what did you do? Eight times 2. Okay, so she multiplied times 8 across the table. Now we have to write a ratio. What ratio should we write to describe the table? Leilani.
16.
Sure. 2 to 16. Can we write that in a simpler way? Devin?
Yeah.
What could we write?
2 times 8.
2 times 8?
And then 16.
Well, if you divide by
With 8.
if you divide by 2 on this side, what do you have to do on this side?
Divide
The same thing, right? So what would you get?
8.
And what goes here?
8.
2 divided by 2. 2 divided by 2 is 8?
No. That's right. No, it's 4. What?
Columbia, give me 5.
I'm sorry. People will look at me.
I asked for 5. Hands down. We need to be able to talk this through, and people cannot focus and pay attention when you're laughing, okay? I understand we make funny mistakes sometimes. Okay, I divided 16 by 2 and I got 8, so what do I do to this left side, Davian?
It equals 1.
It equals 1, why? What'd you do?
Well, you know how you said divide 2 by 2 to
Yes, so I divided this side by 2, so I had to divide this side by 2, and 2 divided by 2 is 1. So here's the ratio that describes the table. Multiplying by 8. Okay, exercise 1. The following tables show how many words each person can text in a given amount of time. Compare the rates of texting for each person using the ratio table. So, the question asks us to compare their rates. So maybe we need to find out who texts fastest and who texts slowest using these tables, okay? So yes.
Oh, I have a question. Well, not really a question.
Okay.
Well, I was saying, because, like, I know this last year, they tricked us because they're saying a lot of people think that the biggest number is
Nice. So Adriana says it's kind of tricky because sometimes you think, oh, this is the biggest number of words, right? 90, 150, 90, and 120. So obviously Michaela texts the fastest. Is that right? No. Why? Why, Persephone?
Because that's how many letters each.
No, it is how many words. Leilani, why is that not right? Leilani? I'm sorry. Yeah, Leilani?
Me?
Yeah.
It's like it's switched.
What's switched?
The
Liliana? You have to pay attention to the minutes. Michaela can text 150 words, but it takes her 3 minutes. Jenna can text 90 words, but it takes her 2 minutes. And Maria can text 120 words, but it takes her 3 minutes. We can't really compare these clearly. We need a common factor in our ratios so that we can compare the number of words per minute. So we can just find the value, right? If I find the value of the table, I can compare values. So what's the value of Michaela's table? Ricardo, how do we find it? Okay, we're gonna write this as a fraction, good. Can I do anything to that fraction to make it simpler? Really? Could I do anything to it if this 0 wasn't here? Huh? No, if the 0 wasn't here, could I do something to it? If the fraction was 3 over 15? Rocco, what could I do?
We could kind of like multiply or like kind of like basically like dividing or no. For me, I will multiply like one of those two, and then I will subtract and see who
Okay. Dasani, if this 0 wasn't here, could I do something to this fraction to make it simpler?
yeah.
What could I do?
You can divide it.
Divide by?
Divide by 5.
Can I divide 3 by 5?
No, sorry.
No.
3. Oh my God. Divide 3 by 15.
Oh. 3/15. What can I do to it, Susish?
You can divide it by 3.
Yep, I can divide both sides by 3.
Yes, I knew it.
3 divided by 3 is?
1.
150 divided by 3 is?
50.
50, right? Because we're looking at it without the 0, but we have to remember to put it back. Okay? So the value of this table is 1/50th. Now if I rewrite the value as a ratio, how do I write it? You can say it. 1 to 50. What does that mean in the context of this problem? Leilani.
That took her 1 minute to write 50 words.
Yes, because she wrote 50 words in 1 minute. She texts 50 words a minute. Go.
I could do that.
Devin, go. Okay. Now Jenna, the ratio we circled was 2 to 90. How do I find the value of Jenna's table? Marina.
You multiply 1 to 20 to 3.
What? What?
Where did you ask?
I'm on Jenna's table. I've written the ratio that we circled, the 2 to 90. I want to find the value of this table. How can I do that? Divide what?
90 to 2. Or
90 divided by 2?
2 is 90.
2 divided by 90. Remember, order matters. So you have to always keep this in the back of your mind. Right? First number goes on top. Okay. Can we do anything to this fraction?
Divided by 2.
I can divide both sides by 2. 2 divided by 2 is?
1.
90 divided by 2 is? If I rewrite this as a fraction or as a ratio, what does it look like?
1 to 45.
Yeah. What does that mean, Ricardo? Jenna texts 45 words in a minute. Now let's look at Maria's table. What do I write first? I want to find the value. What do I write first, Julia?
The ratio is 3 to 120.
The ratio is 3 to 120. Then what, Michaela? Yeah, how do I write it? Yeah. Can I do anything to that, Javier?
Divided by 3.
I can divide both sides by 3. 3 divided by 3 is? 120 divided by 3 is?
40.
If I write that as a ratio, 1 to 40. So how many words per minute can Maria type? 40. So now we can compare, right? We're comparing to how many words they can write in 1 minute. So it's fair to look at the second number and get an idea of who is texting the fastest and who is texting the slowest. Who texts the fastest, Cecile?
Michelle?
Michaela.
Oh, that's Michaela.
Michaela. The fastest. Who texts the slowest, Tony? Maria.
Wait, I thought it was Jen.
Now. No.
Oh, okay, why?
Michaela is the fastest because she writes the most words in 1 minute. Maria is the slowest because she writes the least words in a minute. And Jenna's right there in the middle. Okay? Turn the page. Now we need to make a table that shows Max is texting at a rate of 55 words per minute. If I can type at 55 words per minute, what can I put in the first 2 boxes of my table, Dewey? 1 minute and 55 words. Take a moment to fill out the rest of your table. Give you about 20 seconds. Jeffrey, share the bottom row of your table. What goes here? 110. How'd you figure that out? Yeah, you just multiply by 55 to get the second number. And words per 3 minutes, Shay,
3 times 55.
is 165. Now how about 4 minutes, Adriana? That's right. 220. Huh? You said 220, right? That's right. Good. Okay, let's add a little bit more to what we know. I need Kevin to read us part A of exercise 2 on page 50. Concentrate. Nice. So, the greatest water to juice concentrate ratio. If someone has the greatest water to juice ratio, is there more water or more juice? More water. Okay? So this is asking who has the most water in their mixture. And whose juice would taste strongest? Would it be the person with the most water or the least water? The least water, right? The least watered down juice. Okay, so let's look at Laredo, Franca, and Milton's juice tables. We need to put the juices in order from the juice containing the most water to the juice containing the least water. Can you tell right now, just from looking at the tables, who has the most water and the least water?
Yes.
You can?
Yes.
Wowzers. What do you think, Sasir?
You can, because if you look at the later juice, I don't know
If you look at what?
the first chart,
Laredo?
you can tell that it has a column for water. And so
Mm-hmm.
you can tell how much water he put per
Okay,
how
now,
many
so
steps.
compare how much water Laredo put to how much water Franca put in her juice.
The radio put 5 ounces or gallons or whatever.
Let's do cups.
5 more cups of water than Franca.
Interesting. Kalia?
You can't see like how much water like how there was so like how Franca and Milton have like 2
Mm-hmm.
ounces for juice or something.
Sure.
2 ounces.
But Laredo has.
4.
So we cannot compare them, right? Because we don't have the same amount of juice concentrate. If Laredo has 12 cups of water and 4 cups of juice, and Franca has 10 cups of water and 2 cups of juice, that doesn't really help us. Right? We can't compare these two values, these two ratios, because they have nothing in common. We need to have one number in common. How can I make that happen so that I can compare them? There are lots of ways to do it. What's an easy way that you can find? Turn and talk with your partner. Bring it back in 3, 2, you're at a level 0, and 1. Good. Vivian, what can I do to figure this out? I need to compare them. Got to be able to compare each of these ratios. So what do I have to do to this one? What do I have to do to this one, Jordan? I have to add what?
12 to 4.
Davian, help him out. What do I do to the first ratio so that I can compare it to the second ratio? Multiply what? So I have 12 to 4 and 10 to 2 and 8 to 2. But I want to be able to compare all these to each other, so I have to make one number the same in each ratio.
See if there's a number equivalent to all of them.
Do what?
See if there's a number equivalent to all of them.
Okay, see if they have a common factor.
Yes,
Okay, do we?
they do.
Mm-hmm. Can you tell me the answer? What do I do to this ratio so that I can compare it to these two ratios? Okay, I use the little, okay, that doesn't really apply in this example. Remember, we're learning today about scaling up and scaling down, so that's probably the skill we're going to be using, right? Mo said, what do I do? You could write them as a fraction, you could. You don't have to though, right? You don't have to. Tara, what could I do? Divide by. If I divide both numbers by 2, what ratio do I get? Say it. 2, 2, and 2. So now we're comparing the amount of water in each mixture when we have 2 cups of juice concentrate. Itzel, go ahead. Okay, so can we compare fairly our juice now? Yeah, we can. Whose juice has the most water? Dewey. You can say 1, 2, or 3.
Or
Okay, this is water.
Oh, no.
Dewey?
Right.
Franca. Who has the least amount of water, Leilani?
Me?
Yes?
Milton? Wait, no.
Okay. The ratio is water to juice concentrate. Water to juice concentrate. Water to juice concentrate.
It's, Laredo's?
Laredo. Laredo has the least. He has 6 cups. Franca has 10, and Milton is right in the middle with 8. Yes, sir.
The first one, the ratio should be 3 to 1.
Sure. See, there's lots of ways to do this, right? We could find the value of each table. And like Wesley said, up here it would be 3 to 1. Franca's would be what, Wesley? 5 to 1. And Milton's would be what, Kalia? 4 to 1. Leilani? Okay. So explain how you use the values in the table to determine the order. How do we use these numbers to determine the order of people? What did we do? Who can explain it? Adriana. We divided. What's the new word that we learned today? We divided so that we could, what, Kalia? So we could scale down, right? So we found a common factor and we scaled our ratios to that factor. And in this case, that factor was what? What was the factor that we scaled to in this case? Say it. 2. Yep. Now, what ratio was used to create each table? How do you know which one was used to create each table? Kalia.
You scale down the ratio.
Yeah, you can scale it down as much as possible and find the value, or you could just take the first ratio of each table.
So it'd be 12 to 4.
Mm-hmm. So if we have these ratios, the next part on page 51 says, explain how that ratio that you found for each table, how it could help you compare the juices. Turn and talk with your partner for 10 seconds. How do we use the ratios to compare the juices? Go ahead. Bring it back in 3, 2, and 1. Who can explain? Who can explain? Whose partner had a really good answer? Anybody else? Devin, go ahead. Devin, tell us what he said.
So, by multiplying and then you your answer.
Leilani, go ahead. Kalia, help him out. Okay, we did, and we found the ratios, right? And then what did we do with them? How come we could compare the ratios after we scaled them down or up? We compared the ratios by looking at the numbers that were different. The values that were different, right? We got them scaled so that we had one number the same for each ratio, and then we used the other number to compare the ratio. Part B, the next day, each of these people made juice again. They love sugar, huh? Making more juice. They made apple juice this time. We done? Whose juice has the greatest water to juice concentrate ratio, and whose juice would taste the strongest? So does this question ask who has the most water or the least water? Who has the most water? And if your juice tastes the strongest, do you have the most water or the least water?
The
Least water, good. Now, let's look at our values again and put them in order. This is exactly like part A. You have 3 minutes to work with your partner. Put our juices in order from strongest taste to weakest taste. Go ahead. There is more than one way to solve this. What did you do, Liliana? Okay, she wrote the first ratio for each one, right? 12 to 2, 15 to 6, and 16 to 6. Then what? Yeah, so we scaled this ratio up or down? Up to 36 to 6 by multiplying by 3. Now can we compare each of these ratios? Absolutely. So this is water to juice concentrate, water and water. So if you have the strongest apple taste, do you have the most or least water? Say it.
Least.
Right. So who has the least amount of water? Say it. Mm-hmm. If you have the weakest apple taste, you have the most or least amount of water? Most. It's watered down, right? It's weak. So who has the most amount of water?
Milton.
Ooh. Ooh, 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 ooh. Pause. Raise your hand if you have an answer. Nice. Marina? It's Laredo. How do you know that?
As you can look at the ratios.
Because you can look at the ratios that are scaled correctly, right? The 6 is the same in every one. So we look at the other number. Laredo has 36 cups of water, Franca has 15, and Milton has 16. So he's right there in the middle. Anyone solve this differently? No? Could I turn these 6s into 2s?
Yes.
Could I? Can I divide 6 by 3 and get 2?
Yes.
Yeah, can I divide 16 by 3 and get 2? Nah, it's easier to work with whole numbers, so not going to go that route, right? Yes?
I thought She said Laredo in the middle, and then it was Milton.
Laredo has the most amount of water, so Laredo's juice is the weakest.
Okay.
How did we use the values in the table to determine what order these would go in? Yes.
I sort of copied the last one,
Mhm.
but I just said we found a common factor to go to that factor of 6.
Yep. We found a common factor,
Number 6.
which in this case, yes, was 6, and scaled our ratios to that factor. Well, we only had to really scale one of them, right?
Miss, I put we found
Just a
common
moment.
factors.
Raise your hand if you have a question or something to say. Leilani,
How did you know to scale that one?
how did I know to scale this one up? Because it was 1 out of 3 that had a different number here,
Okay.
right? Right. If I could scale this down by 3, so if it was 12 to 6, I could have divided these by 3 and these by 3 and scaled them down to 2. But this was the only one that was different, so it's easier to just mess with 1, right?
I didn't understand what
You can go after Javier. Okay, what ratio was used to create each table? Can I find the value of each table and reduce it?
Yes.
Yeah. So, 12 to 2. Can I write that in a simpler way?
Yes.
Yes. Let's see, what is it?
6 to 1.
6 to 1. How'd you find that?
Because I divided 12 and 2 by 2.
Yes, she divided both sides by 2. Now pause. In the last question, in part A, we converted our ratio into a fraction value and then back into a ratio. Do we really have to do that? No, we don't, right? That's a good step to keep when you're learning how these problems work. But you understand that we can scale our ratio up or down as long as we use the same value on either side. So if we divide by 2 on both sides, yes, we get 6 to 1. We've scaled it down as far as we can. How about 15 and 6? Sissy?
You can divide it by 3.
I can divide each side by 3, and what do I get?
You get 5, 2.
5 to 2. Why isn't there a 1?
Because 3 is the greatest common factor.
Because 3 is the greatest common factor. There's not another number I can divide by to make my ratio smaller. So that's my simplest ratio, my simplest whole number ratio. How about Milton's? Dewey, how can I find the ratio they used to make this table? Well, I have 16 to 6. What can I do to it? What's the common factor? 2. And what do I get? What's 16 divided by 2?
8.
What's 6 divided by 2?
30.
So Laredo's ratio is 6 to 1, Franca's 5 to 2, and Milton's 8 to 3. So we've just found the simplest whole number ratio we can. It's okay if there's not a 1. Okay, let's look at lesson 11, page 52. We're going to go ahead and skip to part C. You have 5 minutes to work with your partner on part C at a level 1. compare the ratios of juice concentrate to water by using ratio tables. State which beverage has a higher juice concentrate to water ratio. So what value are we writing first? What value are we writing first, Itzel? 4 to 15. Now why did you write the 4 first?
Because it says from juice to water.
Yes, it says juice concentrate to water. So our ratio tables are juice to water. Now whose ratio is 4 to 15? Yes, Max. Max mixed his juice this way. Now how did Sheila mix her juice? Vivian. No, you had it. 3 to 8 because the problem asks us for juice concentrate to water. So we write juice first and then water. Okay? We're going to try to compare our ratios using ratio tables. So look at our numbers for juice concentrate and our numbers for water. Which set of numbers would be easier to find a common factor for? 4 and 3 or 15 and 8? Shay?
The 4 and the 3.
The 4 and the 3, right? 15 and 8, they probably have a factor in common, but it might take us a day and a half to find it. Ooh. 4 and 3, what factor do you know of that they have in common? 12, right? That's pretty simple. Let's count by 4s until we get to 12. 4. Oh, there it is. So now we have to match up our values on the right. 15, 15,
30, 45,
35.
okay, and I'm counting by 3s for Sheila because she used 3 cups of juice concentrate. So 3,
6, 9, 12.
oh, there's our 12. Now we have to match up our water values on the right column. So 8,
16,
24, 32.
okay. Which one has more juice compared to water? Raise your hand when you know. Which one has a higher juice to water ratio? Turn and talk with your partner about which one and why. Columbia, give me 5. Nice, hands down. Vivian and Julia, what do you think? You think Sheila has the higher juice concentrate to water ratio, and how did you figure that out?
because she has less water.
Yes, because there is less water in her juice concentrate. So relative to the water, she has more juice concentrate than if she had 45 cups of water like Max.